Hello everyone and welcome. This is a short YouTube about Sketchup 2024. I just wanted to introduce this myself. I do have a YouTube channel. I invite you to subscribe. I think you'll like it. I have a website. That's the name of my website. And you can go to the menu and then to look about stuff about the robot, you can go here. To look about stuff about the drone or other topics, you can go there. I do work to design physically real items, and on any physically real item, it could potentially hurt someone. If you have a physically real item, you should manage it in a way that is legally allowed and reasonable and safe. And if you can't manage it in that way, my advice is don't create it as a physically real item. And this was a poster session that I put together to talk about the robot hand, which I'm working on. It's a design, but I want to go to SketchUp 2024 and just show you some stuff in it. I think it's very impressive, particularly the new video capability that it has. And so we'll switch over to SketchUp. Let's see what everything's coming up roses, although I guess it's not really roses. This is don't know where this is, but anyway, that's our background in Bing. And we want to open SketchUp. And now we're in SketchUp 2024. It allows picking what graphics system you want to use. And I have a NVIDIA Quattro RTX 4000, and it lets me pick it. These are, I designed some robots. I wanted to design a robot that completely mimics a human being, and arms and legs and hips. I wanted the arms to be strong enough. They're running off of these hydraulic cylinders. This is 2205 alloy stainless steel. This diameter here is a 1/4 inch, and the strength of that, so you can measure that, and that diameter is a 1/4 inch. If you use 2205 alloy stainless steel, the tensile strength of this at 65,000 pounds per square inch, yield strength is 3,000 pounds. So the shear strength would be 1,500 pounds. So this shoulder is strong enough that the robot could do a push-up, it could do a pull-up. But in terms of SketchUp 2024, when I wanted to show different positions of the arm to show that this arm has the range of motion of a human. And in the old SketchUp, you couldn't move around like this, but it does it with just no problems. You can see how you get your hand out behind your back and put your hand up in the air and bring your hand up forward and rotate. You can rotate your arm up. All of this is possible with this design of this robot, and I haven't been able to really describe it very much because I couldn't get SketchUp to show it, but there it is in the new SketchUp 2024. And here is another SketchUp file. I created this robot and I wanted it to walk like a human. The hips and legs have the same range of motion and joint types as a human, and I was worried. I think people would go, yeah, well, that's a great design, but it can't walk like a human being can walk. And so I thought I would divide one stride into 20 different stances to show the robot. You know, it starts out on its right foot and it swings its left foot forward and puts its left foot on the ground, and at that point it puts its weight on its left foot, so it leans to the left, and it lifts up the right foot and starts walking and put the right foot forward and brings itself back to where it was. This used to be in SketchUp a file that I could not show because SketchUp couldn't display it, but I can show it here. It's really nice. It's just no problem to it at all, which is great. And in the old SketchUp, I didn't put these shafts in here because as you add more and more structure, it becomes an unworkable file drawing. But my bet is I could put that in there and demonstrate the robot walking. I was intrigued with a heavy lift drone, a nice big structure that you could put people in it and carry a heavy load. These propellers are actually drawn from a specified actual propeller drawing. So they're not just for decoration. That's the way it really would look. This is the bent axis, Parker Hannifin bent axis hydraulic motor that I'm using to spin the propellers. This drone is big enough and heavy enough that it would be expensive. And I wanted to try to figure out some way to make a drone like this. I believe with the drones, the biggest issue is going to be a stable hover. And the truth of a hover, if you're hovering 6 inches off the ground and stable, then you can hover 6 feet off the ground or 60 feet off the ground. There's no real difference. So if you want to modify or optimize your drone so it can have a stable hover, there's no reason why you can't do that when it's 6 or 7 feet off the ground or whatever this distance is. It's not very high. And I wanted a structure to hold up. This test drone would probably cost $80,000, and you don't want to crash it, but you want it to be able to hover. And I created this design for a cardanic joint that allows the drone to tilt around. I have to be careful. Sometimes I get down inside of the drawings, but this is a ball bearing cardanic joint that this one is a solid one. It doesn't change its length, but these two are hydraulic cylinders, so they can change their length in order to allow it to tilt. And so that would allow this drone to be on this support stand, and you could optimize your hover. And the support stand I was working on, okay, so, and the drone is sitting on this type of a structure, and this holding device can go back and forth in this direction and back and forth in that direction, and that is done by these hydraulic cylinders. And the holding device uses what it's called a ball slide. It's a device that they use in the material handling industry, like at airports, the giant aluminum boxes full of your luggage. They put it on a roll away or a rolling conveyor, and these things, this is drawn to scale. This one can hold up 3,600 pounds. So I put it together. It has disc springs on it to hold up that kind of weight, but I put a little spring on there that can take 100 to 200 pounds with a force gauge here. So when you put this drone on top of this structure, the drone can try to fly, and as long as it's okay, nothing goes wrong. But if the drone starts to get out of control, then it begins to bang into these ball slides, and they don't let it move where it's not supposed to. And I wanted to show that you really could create this. And I discovered that, again, in the old SketchUp, this is complex enough that you couldn't show it, but you can see it just well. And I use a style of construction like the anatomy, human body anatomy, where you take one little part that works and you make more of them and put them together, and you take that unit and put it together with more of them. And so now you have 4 of them all the way around to support this support post that this drone is bolted to. And that used to be not really feasible to show in SketchUp, but it's working fine here. The way this safety support system works, the drone is here, it's in this holder that's supporting it. These are springs that push down on force sensors so that if the drone pushes north, the computer system moves this north. The drone would never know it was connected to this unless it has a significant abnormality, at which point these disc springs would bottom out. These can support 3,000 pounds. The whole system would lock up and the drone would be prevented from crashing. And I wanted to demonstrate this stand that I created. It can tilt right, tilt left, it can tilt backwards, it can tilt forwards, 30 degrees. And I wanted to show it with the drones on it and the cardanic joints supporting the drones. And this drawing, and again, this is it's not just a it's not just a toy drawing. It really is an actual propeller. And I wanted to show this support structure holding this drone up at these various amounts of tilt. So, for example, forward tilt, and here is forward tilt plus right tilt, just to show what it could do. My feeling is if what you're working on is a stable hover, 30 degrees of tilt is enough. I mean, if you can't get it to hover in less than 30 degrees of tilt, you need to talk to your programmers. And I've always wanted to show this and discuss it in more detail, but I couldn't get Sketchup to show it. And I did do some math and geometry on this, and I haven't been able, I can't remember where I put it, but this might not be completely stable with only 3 of these. And it may need more, but the concept is what I wanted to show. And now that I have Sketchup 2024, I can show it. It just, the display doesn't seem to bother itself at all to show this any way you want to show it. Another topic I wanted to address was creation of a human mimicking robot hand. I don't understand. It's not that hard to duplicate the anatomy of humans in the sense of how humans do things. They take a small structure that works, and then they duplicate it, and then they put a group of them together to create one structure like this index finger, and then to make the other fingers, they're all exactly the same, except maybe a little bit different length, but they all use the same set of parts, and they all function in the same way. And you can, like, this distance here is 4.5 inches. And this index finger is 4.8 inches. This is a very nice human mimicking robot hand. And I wanted to demonstrate that it was constructed where the thumb can be under the palm, so the thumb can oppose the fingers to do pinch, to do delicate pickup. But you also could start to move the thumb sideways away from the hand. And then you can move the thumb up into the air and get the thumb out of the plane of the palm of the hand. So the robot could do a push-up, or if it fell down, it could put its hand out. Now this entire hand, this is the wrist here, but this entire hand structure here can move down on these cardanic joints that I'm showing here, so that the hand becomes, right now the hand is elevated above the wrist, but the hand can be moved down. So the robot would be able to land on its hand and try to keep itself from getting hurt. And also it would be able to use its hand to push itself back up to get back up again. But if it wanted to pick up a delicate structure, pick up a raisin or a toothpick or something like that, it still could do that. This used to be a drawing that was just not feasible to show this in SketchUp at all. And here it is, and I think it's beautiful. I adjust the opacity of my structures so you can see through them to see what's going on. The real one, this would all be just gray metal, and I also put colors in there so you can see the different parts. And all of this is being done in SketchUp with just no problems at all. This is so much better than what it used to be. So anyway, congratulations to SketchUp. I'm impressed.